I thought I'd walk through the key of this test, and there's a few questions on this test that you don't have to know how to do for the test, so I'm gonna just mention a few little things as you move through it. I would expect definitely having significant figure questions, and definitely expect them to involve zeros. I said this before, but that 0 in the middle, that one always counts. It doesn't matter if there's a decimal or not. The 0 in the middle always counts. If there's a decimal, the 0 at the end also counts. If this had been this number, this 0 would count, but this one would not, because it only matters after decimal. Those matters only matter after a decimal. So all the real numbers count too. So this guy right here has got 1, 2, 3, 4, 5. And if you were given this guy, he only has 4. Okay, so the phrasing of this one, they're asking how many seconds. So the answer need to be in seconds. And if you're not sure, just like look at the answer choices because they're all in seconds. How many seconds will it take a car to travel this many yards if it is traveling 65 miles per hour? So this is kind of tricky because there's definitely a few extra little things in the problem. Here's my suggestion. When you see a lot of numbers, rewrite anything that has a per, like this, 65 miles, either like that or rewrite it as that. And this problem already says something else about a mile. It says right here, they're saying something else. It says a mile is this many yards. So we also have how 1 mile equals 1760 yards. So my suggestion is don't start with either number that has 2 units involved. So see how like there's a unit and a unit, or unit and unit. Don't ever start with those. What you want to start with is the thing that has 1 unit. And people struggle with knowing how to start. So look for the thing that has 1 unit, start with that. That's why we have the 100 yards right here. And I always like to say, go ahead and write all your units in. So there's your yard, canceling out the yard. And if you're not sure where to go, then look through the problem that you wrote over here. And here's a yard. So a yard goes into a mile. I wouldn't put the numbers in yet. I would just put the mile part in. And then immediately write the word mile below. And then you look back around and you're like, do I have, and you might even want to cross it out if you've used something like a conversion. And look over, okay, do I have something that's a mile? Ah, I got a mile. So then there's my hour. And go ahead and automatically put down my hour. So I got that good. And then you're looking through and you're like, okay, so right now what I have is minutes, but it says it needs to be in seconds. Oh, you can get it to seconds. So minutes and then into your seconds. Then you go back and you can put your numbers in. I just think that's a really good way to do it until you're really comfortable with it. So 1 mile, and we do all of our conversions. All right, so most of the time, this is going to tell you how many sig figs to put in. But in this case, we have something that is not a constantly known conversion. So I'm going to show you examples. So right here, this is exact. We know there's exactly 60 minutes in an hour, and this is also exact. So we don't have to worry about those two guys. And if we have something where it says like 1 mile is equal to this many yards, that is also considered, sorry, I went back too far. That is also considered exact. But there is one number in here that's hidden that isn't. When we're traveling or we're driving, our car is not going to be doing 65 miles an hour all the time. It's just not. Even on cruise control, you're going to go up and down a hill. It's not. So be very careful. If we have something that's like a speed in there, you want to be really careful because he's the guy who's setting how many sig figs we've got. 1, 2, 1, 2. All right. Next question. Atomic number 15, mass number 33. So atomic number 15, atomic number is the number of protons. So 15 goes on the bottom. Mass number is the top number. Also, the top number should always be bigger. Like it should always be bigger on top because it's got protons plus neutrons and this is just the neutrons. So that alone tells you that it can't be this. I'm sorry, it could be that one. That one, it can't be that, or it can't be that. Now you're going to look up who this is. And on the periodic chart, if you look that up, you're going to see that that's phosphorus. So when we're doing the molar mass of this thing, that 2 also applies to him and to him. And the 4 applies just to him. So from the periodic chart, you've got your nitrogen, which is your 14.01 times 2. You've got your hydrogen, which is 1.01 times. Now there's a 4 there plus times 2, so times 8. And then you've got your sulfur, which is 32.08. I think I'll have to look on the chart. 2 point something like that. It's 32.06, sorry. 32.06. 07. There we go. You just add those up and you should be getting this number right here. All of our numbers on our periodic chart are to the 100th place. So I would expect that your answer choice needs to be going to the 100th place. That's based on the charts that we hand to you guys. So we got chloroform here, and we've got a molar mass, and then it's asking how much is that many moles. So this is a really straightforward problem. You just start with, again, the thing that has 1 unit. You got your moles. You're going to turn your moles into grams. And the number goes beside the gram part, and this is understood as being 1 mole. And that's why there's a 1 there. So just multiply. Sig fig wise, we're going to assume that the numbers on the chart, because we give them to you to the 100th place, so they're not really exactly, but because we give them to you on the chart, you can treat them as being exact. So I'm going to put a little squiggly because there may be another professor who completely disagrees with that. So we've got 1, 2, 3 sig figs. So that's why our answer choice has 3. All right, so how many chlorine atoms are in this many moles of this guy? So notice now we're dealing with a chlorine atom, which is a Cl, and not the whole compound. We're just dealing with one of them. That's one of those ones where you're going to go internally. So you take your 0.315, so you still got him. And what you're going to need to do, and there's more than one way of doing this. A lot of times I change in this step. So this is how I do this one a lot. Is I'll say 0.315 moles of CHCl3, and then I say in 1 mole of CHCl3 I have 3 moles of chlorine. And then I go and I say in 1 mole of chlorine I have 6.022 times 10 to the 23rd atoms. You can do it either way. I just usually do this conversion on the mole step. And the 0.315, this is also telling us our sig figs. It should have 3 sig figs. I'd be really suspicious if you ever end up on any chemistry test with just 1 sig fig, because it's hard to grade tests that only have 1 sig fig. So isoelectric means that on the periodic chart, well, or just when you're looking, isoelectric means that it has the same number of electrons. That's what isoelectric means. And this one wants to know what is not isoelectric. So we're looking for things that don't have the same number of protons. So you want to grab your chart if you go to calcium. And if you know how to do this where you're moving backwards on the chart is totally fine, or moving forwards. But calcium normally has 20. And this is looking at the electrons. So if it's positive, it's lost 2 electrons. So he's got 18. And then the sulfur, he normally has 16. And he's gained 2 electrons. So he's 18. So this is isoelectric. And notice we're looking for something that is not isoelectric. So our sodium, he normally has 11. But he's positive, so he's lost 1. So he's got 10. And then we look at neon, he's neutral. He's got 10. So this is also isoelectric. If we look at our potassium has 19, and he lost an electron, so that's 18. And then we've got our chlorine, he's 17, and he's gained an electron, so he's 18. So again, still isoelectric. Magnesium, he has 12. So again, I'm looking at the chart to grab all these numbers. I have a chart right here beside me. So that puts him at 10. And then sodium, he's positive, so he's losing 1, is 10. And last but not least, we got chlorine. So chlorine normally has 17 and it's negative, so that gives him 18. And then bromine has 35, and he's negative, so we're adding an electron, so that's 36. So you can tell those are definitely not the same number of electrons, so this would be not isoelectric, which is what they're looking for. So on number 8, how many meters? So you just take the number that's given, that's a millimeter. This would be on the chart that's given to you. You're going to look up and make sure that you've got this relationship. If you're using the chart, the way you're using the chart, it's going to be that in 1 millimeter, there's 1 times 10 to the minus 3 meters. That's how that chart's going to read it. Both of those methods will give you the same answer, but I'm just telling you, if you're using the chart like we've been using, that's how you want to work that problem. All right, so I'm seeing a problem. I'm seeing the word mass, so that's my M. That's my D, and ML, that's a volume. So this is how to work this problem using factor label. It always works for density, so you can do that. We start with anything that has 1 unit, and we treat this like a conversion where this is 1 milliliter there. So you can do that. But you can also use the equation. If you use the equation, just make sure you use it right. We know that density is equal to mass over volume. And I'm assuming that you can move this around to get that volume by himself. You're going to have to multiply both sides by V. So that one cancels. And then you're going to have to divide both sides by D. So volume is equal mass over density. Our notes have this spelled out for you multiple times. You can go back and look at it if you're not sure how to do it. But so having people solve for volume is a really, really good thing to test to make sure they can move their variables around and they know the difference in mass and density. So you got your grams there over 0.789 grams per milliliter. And then your grams cancel. You're left with a per milliliter on bottom, which ends up making a milliliter on top. They both have 3 sig figs, so you'd expect to answer with 3 sig figs. All right, so questions about the elements aren't on this test. So this would not be on there, but we definitely are going to be talking about it, but that's going to be on the next test. So we're looking for the most abundant of potassium. If you look up on the periodic chart, this is the way potassium looks. It's a 19, a K, and then 39 point, and there's a lot of decimals, but 0.10. So when you're looking for the most abundant isotope, you're looking for the thing that has the closest whole number value to him. So you're looking for something that has a 39 in it. This is in here on purpose because they're thinking you're just going to grab it off the chart. So you're looking for the 39. And you're not going to be given a question where there's like a 50-50 mix of the isotopes. So to get to the electrons, you're going to have to be dealing with the charge side of these different atoms. But you also, to do anything with this, you still have to figure out your protons. So that's what these numbers are in here. If you're looking at a chart, zinc, I think that's, zinc is 30. So 30, -1, I'm sorry. If you like the equation, you can, hopefully you're getting to the point where you can kind of just think about this. Is 30 minus your electrons. So -1 minus 30 is equal to your negative electrons. So negative 31 is a negative electrons. And so what that's going to end up giving you is a positive 31. Zinc, again, 30. This is just that 1 is equal to your 30 minus your electrons. So 1 minus 30 is equal to your negative number of electrons. So negative 29 is your negative number of electrons. So 29 is your number of electrons. Gallium, he's 31 right here. Phosphorus is 15. And since this is neutral, that's how come he's 15. And then gallium is 31. Pretty sure if you follow the same format, you can go through this and you can figure out which one is the right answer. It's wanting to know which one has 31. But if you do this one, so plus 1, I'm sorry, it's wanting to know which one has 30. Plus 1 equals 31 minus your electrons. So 1 minus 31 is your negative number of electrons. So negative 30 is your negative electron. So 30 is your number of electrons. So there you go. That's why this one's 30. You can go back and work this one to make sure you see that it's 29. Again, this is periodic chart stuff. This is going to be on the next one. How many moles of oxygen are equal to this many atoms? So this is just a straightforward atoms to moles. So there's your atoms. You're going to use Avogadro's number to get to moles. This is a pretty straightforward math problem, not tricky, not lots of stuff in it. Okay, which one has 3 valence electrons in the 4th energy level? So this is definitely chapter 3. And the way these work, so you have your 1s, and then you have your 2s and your 2p. You have your 3s, 3p, 3d. You have your 4s, 4p, 4d. It keeps going over. And they fill in a certain way. You can look at the periodic chart and you can like start counting over if you want to. But to get to the 4th energy level, you can't be a 1s, a 2s, a 2p, a 3s, a 3p, or 3d. Like, these are your 4th energy level options. And 4s can only have 2. So, like, zinc, his outermost electrons, like, he only goes to 3d10. Like, that's his max. Like, if you look where he's on the chart in the rows and the columns, he only goes to 3d10. Indium, which is number 49, he goes to 5p1. So he could be a possibility. Gallium. Gallium is, I'm just doing like the noble gas course on these. So this is argon. And then we have 4s2. And then we have 3d10, and then we have 4p1. This is going to be the best way to do it. You're going to want to write the configuration for all of these guys. Now that I'm thinking this through. So here's the 4, and here's the 4. So we have a total of 2 plus 1, which is 3. Whereas like this guy, he's got the argon core, and he's 4s2, but we don't have any more. So he's only got 4 in that level. Indium has the krypton core, and he's 5s2. He's 4d10. And then he's 5p1. So again, he doesn't have 3, he has 10 in that area. Aluminum doesn't have enough electrons. Aluminum's just neon. And then 3s2, and then 3p1. And then thallium is 81. That's number 81. So his core is xenon. And then it's 6s2. Now this one's kind of crazy because it jumps down. It's going to fill all the way. You've got your 4f14, your 5d10, and then we're back up to 6p1. That's why it's gallium. Okay, so the chemical symbol for things, this again, that's on the next test, but you kind of sort of should be starting to get to know some of these symbols. So that's on the next test. The frequency of light with a wavelength. So the equation that you'll be given is that lambda times your wavelength is equal to c. You'll be given that. So you need to be able to rearrange it. If they give you the wavelength, so this is what you have, and you have that because that is a constant. And you need to be able to solve for the wavelength by itself. Also double check on your units. When you put this guy in, he needs to go into this equation in meters. And like when you get this guy, he's going to be seconds to the minus 1 or hertz. So you're going to look for an answer choice that's a seconds or a hertz. Seconds to minus 1. So this equation wasn't immediately used. I'm going to kind of write this over here to the side. We take 540 nanometers. In 1 nanometer, there's 1 times 10 to the minus 9th meters. So that's using that chart that you're used to using. When you solve that, and I'm going to write this out long ways, you're going to get 540 times 10 to the minus 9th meters. Then you can plug it in, and if you don't like rearranging the letters, you can plug it in like this: 540 times 10 to the minus 9th meters times your frequency that you're solving for is equal to 3.0 times 10 to the 8th meters per second. Then you'll divide both sides by the 540 times 10 to the minus 9th. Yes, you can move that number around. It's just because I'm kind of doing this on the fly. I'm not doing it all in my head. And again, that's a meter and a meter, so those will cancel, and that meter will cancel with that, and you're going to be left with a per second, which is a hertz. And when you put that in a calculator, you should be getting this answer right here. Sig fig wise, the 5 and the 4 are what matters. The 5 and the 4, not the 0. The 0 on the right only matters with a decimal. All right, so that's part of the way through the test right here. We'll do a few more of these, and we'll see if my voice keeps lasting. So how many orbitals are in the second energy level? All right, so we know that you can like do 1s2, you can do 2s2, you can do 2p6, and then you start over at the 3s's. You don't have any more 2's after that. You run out of 2's. So this is telling you that there are a total of 8 electrons, but they're asking about the orbitals. Well, here's your 2s. You can have 2 there, you know there's a 2, there's 2. And then you can have 3 different p's. That's where your electrons are in. So you'll notice that we have 1 orbital here, another one, and another one. That's how we say that there are 4 orbitals. So now, if we want about a full third energy level, so again, like if you're going across the chart, so you've got, like before, you can do the 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and you can't get to an F. Like, you don't, the first F doesn't happen until you reach the 4th level. That's like at cerium, like 58. That's the one that starts with the F's. There is no 3D. So like, for example, you can only have like 1S. And you can have a 2S and a 2P. Or you can have a 3S, a 3P, and a 3D. But you don't get to the 4s. I mean, you don't get to the F's until you get to the 4s. And everything after that can have an F. So if we want to know how many are in that third energy level, we're going to say that this has 1, this has 3, kind of the same principle above, and then this has 5. So 1 plus 3 plus 5. Oh, this is actually asking for the number of electrons. If they were asking for orbitals, we would say that there are 9 orbitals. So be careful how you read these. But it's asking for electrons. So it's 2 plus 6 plus 10. How many energy levels are occupied in a bromine atom? So when we say are occupied, we're just asking you for the configuration and just to check and see how far up the numbers go. So this is kind of the outermost. You can tell that you go up to the 4th. You go up to n equals 4. If you were to write this argon section out, you'd notice that you would cover the n equals 1, you'd cover the n equals 2 and the n equals 3. Of course, there's an n equals 3 right there. So this one, how many are occupied? It's just how many levels. It's just those front numbers. Like, what's the largest front number? So it goes up to 4. This is the next test. And this is the next test. Okay, we did talk about this, and so this is something that you need to make sure that you know. They make a 7 on the periodic chart, plus the space for hydrogen. So hydrogen's over there on the chart, so H2. And then N2, O2, F2, Cl2, Br2, I2. Those are your diatomics. Pick one of those. whatever is in the answer choices. Okay, empirical formula. Empirical, the E, that's the easy one. That's the lowest ratio. So this has some extra information in it, and all you have to be able to know for the test is you need to be able to just pick out what is the correct molecular formula. So in this case, the molecular is the multiple. I'll show you how to work it all the way. So you'll notice that this is 1 to 1 to 1. So it could be this one, or this one. To figure out which one it is, it's telling you this is the molar mass off the chart. So you just need to be able to add up. And for this one, you're going to have it's shown over here to the right. The 3 times 12.01 plus 3 times 1.01 plus 3 times 35.45. Add that all up, and you're going to get that right here is the 146 micromole. All right, so say fig-wise, these are all underlined, so that one should be pretty straightforward. Notice that this 0 does not count because there is no decimal. Okay, so what contributes to the charge but not the mass? So if you're just looking at the charge, the protons and the electrons that contribute to the charge, but the electron is 1,000th of the size of the proton. So tiny. It doesn't contribute significantly to the mass. And that's why the answer should be an electron. All right, so now we're looking at something for the same number of electrons. So if we've got this guy, this is just like a little pro tip right here. If we've got this guy right here and he's neutral, that means that he has 23 electrons. It's not going to be a vanadium answer choice. Like, you can't change the charge and still keep the same number of electrons. So it can't be that one. So we're looking for something that has the same number of electrons as 23. So the 2 equals 21 minus the number of electrons. So 2 minus 21 is your negative number of electrons. So negative 19 is your number of electrons. So that one has 19. So that's your scandium one. And this one is 2 equals 25 minus your electrons. So 2 minus 25 is equal to your negative electrons. So negative 23 is equal to your negative electrons. So 23 is equal to your electrons. You'll notice those are the same. You should be able to work the other ones out the exact same way and figure out how many electrons that there are. So with this one right here, you've got a total of, it should be 21, and with this one right here, it should be 25. I'm kind of doing that in my head. We can get to that point too. And then right here, this one's really spelled out well. This is from the periodic chart. When you subtract the 2, that gives you your number of neutrons. And then negative 2 equals 16 minus your number of electrons. So negative 2 minus 16 equals your negative number of electrons. So he's got 18 electrons. You can just make sure you're picking the answer choice that matches with what you know. Which one is a noble gas? Okay, this is also not going to be on the chart, the test. That's on your next test. These questions right here, these are just more of those conversion kind of questions. I'm expecting that everyone's probably pretty good at them right now, and they're all completely spelled out for you. This one right here, this is carbon atoms, and this is what makes this one a little bit different, because it says carbon atoms. So right here, again, we're starting with these moles. We still have to put moles of him. And we're moving into carbon atoms. The reason that the 3 is in front is because that's that subscript right there. And then you just do your math. You're going to need 1, 2, 3 sig figs. We consider this exact because there are exactly 3 carbons in that molecule. Okay. Right here, we did not cover this. This right here is going to be also on the next test. This is also on the next test. This is also on the next test. You need to know this. You need to understand, like, if you're given these different names, you need to know, like, this is going to be the highest energy, the highest frequency, and it's going to be the shortest wavelength. You should probably know the visible range too. That range, it varies. People would say 350 to, I don't know, that's probably the max of the range. Most people can probably see more like in that range. And this is all in nanometers. So here's our electron configuration kind of question. Again, obviously this isn't multiple choice. This is just kind of practice for your electron configuration. But you could see, like, if you were given this one and being given like 5 different answer choices, that you're going to want to make sure that you're picking this. Make sure that you can do these guys with the ions. There's not an example on here, but if you have something that's like CO plus 2, it's argon. And then it has the 4s2. And then 1, 2, 3, 4, 5, 6, 7. So if he were neutral, he would be this. So this is for the neutral CO. To make him so that he has a charge, remember the electrons come out from that place. So argon, 4s0, 3d7. So you wouldn't even have that in there. So this would be what cobalt plus 2 was. Make sure I'm getting to the end here. All right, almost done. How many electrons are in a 3D sublevel? And this is more questions than you would have on a test. So if you can get through these in an hour, that's fantastic. All right, sorry. Okay, so how many electrons are placed in that 3D sublevel? What this just means is that, or 60, is it's a D, and it's 1, 2, 3, 4, 5. And what you're going to do is you're going to take the orbitals, and you're going to put that you have 2 electrons in each orbital. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now remember, that's not how you should fill them, is it? What you want to do is you want to fill it with 1 electron in every orbital position, and then go back and fill it in. But in either case, you've got a total of 10 electrons. This problem right here actually has 2 answers that are incorrect. You can't have a DP. So this is incorrect and this is incorrect. This goes back to what I said in one of the earlier problems. Like you can have 1 S. There's 2s of those available. You can do this. And you can get up to all of everything with the 4s. So if you try to figure out the number of unpaired electrons in a 5p orbital, what's the maximum number? So there's like different combinations. So if we're talking about a p, so you could have 1. There's 1, 2. 1, 2, 3. And then once you go back, you're going to be pairing those guys back up. I know the answer choice is marked as A, but I guess I'll have to add an addendum if I can figure out why this says 3 right there. That's what I would say, is that the maximum number of unpaired electrons in a 5p orbital would be 3. Okay, so if we're looking at which ones would absorb the highest energy, remember we were talking about that atom, and when we're going out from the atom, they get closer and closer together. So the transition that's going to be the smallest energy is going to be between the 2 closest levels, and the largest energy is going to be like the largest distance. You also want to pay attention to this word absorb. absorb means going up. That's positive energy. And then for the hydrogen atom, if it had said like released or emission, then that would be down, a negative energy. So that's like giving off energy. So we're going up. So you would have to be choosing like this answer choice goes up and this answer choice goes up, but the other ones don't go up. And then the one that has, these two are farther out, so they are closer to each other than this one. So the highest energy would be these ones. So what on earth could be invalid about this? Well, the whole deal is that if you have n equals 3, that means your L, it's n minus 1 all the way down to 0. So it means that it could be 2, 1, or 0. Once you get to your M sub L, this could be positive 2, 1, 0, minus 1, minus 2. The M sub L for 1 is 1, 0, minus 1. And the M sub L for 0 is 0. You will notice that there's not a 1/2 in any of those. The only thing that can be a 1/2 is M sub L, and it can be positive 1/2 or it can be negative 1/2. Now for this represents the energy level, so the front should always be 2. So it would be this or this or this. L, when L is 0, that's an s orbital. When L is 1, that's a p orbital. When L is 2, that's a d orbital. So s, p, d. So with L equals 1, that's representing, and we're talking about p. And then this is just one of the p orbitals. So we're looking for something that says 2p. So if your answer choices are things that are like a number and a letter, then it really is just the first two that matters. All right, so how many orbitals are in the sublevel described by these quantum numbers? So again, this is the energy level 3. This is the third energy level. And again, that N, or the L, we already said, when L is 1, it's right here, it's P. So that means 1, 2, 3, that you've got 3 orbitals. 1, 2, 3, 4, 5, 6. You put that many electrons in, but they're not asking for that. They just want to know how many orbitals you got. So you got 3 orbitals. Now, if you're looking at these sets and you want to see what's allowed, I would first go through the first grouping. So the L just needs to be n minus 1 down to 0. So as long as L is at least 1 less, and it's not like a fraction or something, it's okay. So you'll notice that this L is definitely more than, it could be 5, 4, 3, 2, 1, 0. So that's okay. This L, also, it could be 4, 3, 2, 1, 0. So that's okay. This could be 1, so that's okay. But look right here. This L is not n minus 1. And so that's a problem. This is where the problem is. And this L is also okay. So we found the problem. We don't have to keep going. But notice that the M sub L's, they should be positive L to 0 to negative L. So like, for example, this would be 2, 1, 0, minus 1, minus 2. So this one is definitely in this grouping. So you can go through and work out the rest of those other ones for the M sub L's. How many electrons are described by the following quantum numbers? So this is your energy level. That's 4. That means that it's in a D. And then this is being specific. It's telling us which D that it is. It's being specific. So of there being 4 Ds, a 4D, and there being 5 orbitals, it being the minus 2 is being specific. Like we could call this 1, 0, 1, 2, 1, 0, minus 1, minus 2. And it's saying it is specifically this one, so there's only 2 electrons that fit in there. All right, almost done. How many occupied orbitals are in the neutral atom of magnesium? So occupied, that just is saying, so how many electrons are there? And then we're gonna end up dividing it by 2 is what we're gonna end up doing. But this shows you the whole configuration. So this is a total of 12 electrons, and the number of orbitals, because you can only do 2 electrons per orbital, is 6. Or you can count them out that way too. How many levels are occupied by silver? So this one up here said orbitals. That's talking about the little lines, right? It's how many. So this was a line, that was a line, that had 3 lines, and then that had a line. This is talking about levels. So this wants to know how many energy levels. And if you look, it goes all the way out to the 5. It doesn't go any higher than the 5. So it has the n equals 1 energy level, 2, 3, 4, and 5. So it has a total of 5 energy levels. If you know how many sublevels are completely filled in an atom of potassium, again, you're just putting it in. So these are all filled. The one that isn't filled is him. You can see it says half fill. And then this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So if they were asking orbitals, there'd be 9. This is asking sublevels. So that's the same thing as saying L. So you have, this is one type of L, the S's, and this is another type of L. Trying to think. Oh, it doesn't say how many types. So if it was asking how many types of sublevels, then there's S's that are filled and then there's P's that are filled. But this is asking how many sublevels are completely filled. And so we're saying that this sublevel, this sublevel, this sublevel, this sublevel, and this sublevel, that's what it's asking about, are completely filled. And last but not least, how many are in Mn plus 2? So you'll have to remember that there was a 4s2 in there, and it was taken out when it lost the 2 electrons right here. Okay, so this test really kind of went through a lot of the nitty-gritty on the math and like all the numbers and things like that. Some of the things that weren't on this test was this test did not have any kind of an example of any kind of like a percent abundance problem, being able to calculate or dealing with percentages. That's something that was not on that test. Things like the history, this also was not on the test, like the history of the atom. Locations. This test didn't have any physical or chemical like changes properties. Didn't have any of the laws. It didn't have anything about accuracy or precision. And it didn't have, in the light chapter, it only showed like 1 or 2 light. Make sure that you practice more than just the one. I feel like there was only 1 light problem in here. So practice more light problem examples. And I think there's only 1 or 2 metric conversions. So make sure you're feeling solid on the metric stuff. You will be given the metric chart, but make sure you feel solid on that. All right, I think that's about it. Good luck.